Hi everyone, and welcome to the Intro to Python module that I'll be talking you through today. So in this module, we're going to cover a few different areas. I'll start with some basic concepts of programming and try and link kind of back to Excel. So hopefully the concepts that we're using will translate from Excel to writing the same thing in Python. And then throughout the course, I'll then move into more complex Python methods and try and get to a point where you can understand all the basics that you'll need to start thinking more about Python in this course. And then in the next set of videos, I'll talk more about the external libraries and how it all links back into the validation tool that we're working on. What I'll say is that this is definitely designed to be more of a crash course than a really in-depth intro to Python. So what I would suggest is throughout the video, I'm going to be picking out points to kind of pause and think about what I'm coding and think about what the outputs might look like. I suggest doing that on the first look through. Definitely don't feel bad for watching these a few times because I might run through a few things quite quickly. And in general, a lot of what I'm trying to do here is just give you the core concepts and the core kind of keywords that you can then take and Google around and look at the other resources that I'll recommend in the summary materials to build out the kind of side knowledge that you might need. Hopefully, in theory, if everything here makes perfect sense to you, or you've had a bit of programming experience before, this should all feel like a bit of a recap and a refresh. But if you're totally new to this, you might find that you need to watch these a couple times for the core concepts to kind of sink in. Otherwise, without further ado, I'll jump straight in and start talking through this tutorial. So the first concept that's common to all programming and is also here in Python is the concept of a variable. And I think to explain this best, I'll start with Excel. So if we imagine that we have a bit of data in Excel about child ID and the legal status of that child. So these are two fields that you can find in the 903 return. And let's say we have our child here with this ID and the legal status is V4. So if you actually think about what I've done here in Excel, there are these four cells, like A1, B1, A2, and B2. And when I typed in that value, I assigned that value of child ID to cell A1, and this value of 134567 to cell A2. In the Python world, the idea of a kind of data container is called a variable. And all programs operate on variables. And really, most of programming can be boiled down to two things. You define or get your data, either within the program or by doing some input-output with files. And then you operate on the data through the program instructions that you've written. So if I want to, say, replicate cell A2 here for the child ID, I would write A, like child ID, is equal to 134567. And this does two things. It creates a variable called child ID and then assigns to that variable 134567. So this whole process is called assignment. So what I can do now is I can take out the old bit of code from last session, print hello world, and instead ask it to print this variable. And if you pause here, what do you think will get printed here? Hopefully, if you pause there and thought about it, you can hit run now, and you'll see that this prints exactly the value of that variable, 134567. Similarly, say you might also want to print the name of the variable here, which is this child ID name. Because I mean, this variable is called child ID, but we could also call it X and print X. You call it anything you want. In general, good practice is to call a variable by a name which makes it easy to identify. So that's why I've chosen to call it child ID here. And then maybe call the child column title as child ID. Then here I can print the child column title and the child ID here. And again, if you pause now, what do you expect to print here? As you can see, what prints is the string child ID and then the child ID itself. It's worth sort of pausing at this point and looking at the output here and how it's different from what I've written here. So you can see that here when I wrote child ID, I enclosed it in quotes, whereas when I actually wrote the number 134567, I didn't enclose that in quotes. And this relates back to another kind of important underlying concept that exists in Excel but is a bit hidden from you and exists here as well, which is the idea of a type. So every variable has a type, and within Python there's a lot of primitive types that exist, but the main ones that we care about are sort of these number types, which split into two. You have either floats or integers, and you also have a type for storing list of letters, which is called a string or a string type. So Python under the hood tries to guess what kind of type you're working with, but it's worth noting that it won't always guess right, and if it guesses wrong, it will lead to weird situations. So for example, if I get rid of this code for the moment, and we start with just one variable equal to 1 and one variable equal to 2, then if I ask it to print x plus y, you can pause here if you like, but you can probably guess what this is going to print. And it prints 3. However, if I define these as strings by enclosing them in quotes, it's now going to treat these both as lists of letters, and when those are added together, it will just put one next to the other. So with that information, what do you think I'll see now if I run this program again? 12. Because really what's happening here is we're taking the string 1, adding the string 2 after it, and displaying the whole thing. One way to solve this is to explicitly make sure that what you're working with is in the right type, so you can use the int function here, which will print out the which will attempt to convert those strings into integers before printing them, or you can use similarly the float function, which will convert them into floats. The difference between these two is essentially the integers don't have decimal points and floats do. There's a few more kind of details beneath that, but for the purposes of this course, that's all you kind of need to worry about. So if I run this now, again, you can think about what might happen, but what you'll see is the integer version prints out 3, and the float version prints out 3.0, also to indicate that it's a floating point number rather than an integer. I just wanted to record a short video to explain how Boolean types work specifically. So Boolean is a fancy way of saying true, false values. And you'll see them a lot later on when we're trying to essentially validate the 903 and decide if an error is occurring or not occurring in a cell, because that translates in programming into a true or false value. And I think it would be worth just quickly running through the different types of comparison that are available to you. So let's just, again, define some variables. So we have x equals 3, y equals 4. And then we can print all the different types of Boolean comparison. So the types are, you have equality. So for equality, you use 2 equal signs. A very common error would be to use 1 equal sign, but that's the symbol for assignment, as seen here, not for checking Boolean equality. So if you run this with 2 equal signs, as you might expect, we can see that x is 3, y is 4. They don't equal, so this will just print out false. If I change this to 4, this will print out true. And if you get this wrong by accident and only put in 1 equal sign, you'll get an error, which is a bit confusing in this case, and will usually be a bit confusing depending on the context that you've made this error in. So in general, if you're seeing a weird error with your comparisons, just double check that you put 2 equal signs. The other types of comparisons that you can have are not equal, so x is not equal to y, which is this exclamation mark equals, greater than, less than, greater than equal to, and less than equal to. So again, if you pause for a second, you can probably figure out what will print for each of these and look at what's on the screen. Hopefully this makes sense. So because these two values are equal, equality checks and greater than equal to or less than or equal to are true, but the strict greater and less than are false, and not equal is false. Okay, so if we now kind of go back to what we were working before, so we had child ID name, which is going to be child ID. Let's also include the legal status name, legal status, then the child ID, which is 1, 3, 4, 5, 6, 7, and the legal status, which is V4. So now you can combine these all together and create an output which will print the information about this child. So what I'll do is I'll say, right, okay, the output that we want is going to be, let's say, the child ID name plus a space plus the child ID. And then for the legal status output, we'll use legal status name plus a space plus legal status. And then we'll print both of these on the same line, one after the other. So if I pause here, it's a bit of a longer program. I'll just expand this out so you can see. What do you think will be printed here? And I'll run it now. And what's interesting here is a slightly unintended but perhaps helpful error, is that actually, because here we've tried to add a child ID, which is an integer, to the string, and that adding operation is called concatenating when it's two strings, we get this error saying, and I'll just span this out again, can only concatenate strings, not int, to string. But the issue being that child ID is an integer. So how do you solve this? You type str child ID, which will convert this into a string, and then if you rerun, you'll then get the output that you probably were expecting the first time around. Child ID 1, 3, 4, 5, 6, 7, and the legal status V4.